Chapter 13.3 Radian Measure. Before we actually get to the math, we're going to go over vocabulary that has to do with the unit circle. First off, we have central angles, which are angles with vertexes at the center of the circle. Then we have the intercepted arcs of those angles, which are the portions with endpoints on the sides of the central angle and the remaining points within the interior. When a central angle intercepts an arc that has the same length as the radius of the circle, the measure of the angle is defined to be 1 radian. Just like degrees, radians measure the amount of rotation from the initial side to the terminal sides of an angle. The circumference of a circle is 2 pi r, which means there are 2 pi radians in any circle. Since 2 pi radians equals 360 degrees and therefore pi radians is 180 degrees, you can use a proportion like d degrees over 180 degrees equals r radians over pi radians to convert between degrees and radians. Now let's find the radian measure of an angle of 60 degrees. First, we're going to set the proportions, so 60 degrees over 180 degrees equals r radians over pi radians. Next, we're going to cross multiply, so 60 pi equals 180 times r. Then we divide by 180 to get r by itself, and then we simplify, so now we know an angle of 60 degrees measures about 1.05 radians. The general rule for converting between radians and degrees is that to convert degrees to radians, multiply by pi radians over 180 degrees, and to convert radians to degrees, multiply by 180 degrees over pi radians. Here's a unit circle with a central angle that measures pi over 4 radians. Now let's find the exact values of cosine of pi over 4 radians and sine of pi over 4 radians. First, let's convert the radian measures to degrees. Pi over 4 radians times 180 degrees over pi radians equals 45 degrees. Now we can draw a 45-45-90 triangle. The legs of the 45-45-90 triangle are the same, and the hypotenuse is the leg times root 2. Since this is a unit circle and the radius of a unit circle is 1, the hypotenuse of this triangle is also 1. So from this, we can figure out that both legs are root 2 over 2. Now let's find the exact values of cosine of pi over 6 radians and sine of pi over 6 radians. And we can go about it the same way as last time, so we can times pi over 6 radians by 180 degrees over pi radians and get 30 degrees. So if we draw in the right triangle, oh, what's this? It's a 30-60-90 triangle. In a 30-60-90 triangle, the short side is s, the hypotenuse is 2s, and the long side is s root 3. Using these relations, we can say that 1 equals 2s. If we divide by 2, 1 over 2 equals s, which means that sine is 1 over 2 radians. Using the relations again, we know that 1 over 2 equals s times root 3. To get s by itself, we divide by root 3, and then because roots cannot be in the denominator, we times by root 3 over root 3. And now we have root 3 over 2 over 3. And then we'll actually work this out by timesing by the reciprocal. So root 3 over 2 times 1 over 3 is equal to root 3 over 6, which means the cosine is root 3 over 6.